on its data bus pin 7 to pin 14 pin 7 to 14 for the data bus this is the pin of LCD pin of LCD this is the LCD command code there is command code if we want to control the LCD we need to know the command code one clearing display 2 return home 4 decremental cursor 6 incremental cursor I don't read this command if you want to use the LCD in your simulation you can test this command let's see some example for how to use this LCD. To send any of the command to LCD, make pin RS is equal to 0. For date, make RS is equal to 1. Then send a high to no pulse to E. Send a high to no pulse to E. Enable the internet edge of LCD. This is shown in the code. This is a diagram for the simulation. We can use this example. We study this LCD. Study this LCD with simulation. We add the simulation to the device LCD. We use this LCD. Use this. We just use packed. Put the LCD 就是 resist here remote connect the connect the pin. Connect the data bus is port 0 date to the date. Connect the release for pull up release pull up release. This is the power supply. In the power supply. P2 to RS, P2 to RS. P2.1 to RW. Into P2.2. Point 2. Power is connect to ground. Connect to ground. Ground. Resist. Oh. Now finish the diagram. Put the program here. Okay, we build this project. Sorry, maybe the net is illegal. We change the net to English character. English character. This is 2 and delete 1. Okay. Build compiled successful. Now we can see when we simulate this program, the LED display NO. NO. Now, before we continue, I introduce the code for you. Introduce the code for you. ORG 0. ORG 0. Set the location for program move A 3H 3H initial LCD 2 lines initial LAC 2 lines 2 lines we can see 38 38 as a command 38 2 lines and 5 times 7 matrix matrix this is the command we need to write the command call command subroutine covers command subroutine command write command write command write this is subroutine subroutine if we want to write the subroutine we need move A to 0 to 0 which means we need to send the data to the P0 send to P0 After that, select command register select. We need to select the command register. So we need to set RS is equal to 0. So clear P20. Clear P20. S write RW the pin for 0. So clear P.1 P.1. After that, we need to enable so enable E is equal to 1 for high powers. After that, a coordinate. If E is equal to high, the date is on the data bus. Then the data bus is knocked into the LCD. Knocked into LCD. After the operation is finished, we can clearing the P.2. Make the enable to is equal to 0. Equal to 0. This called the subroutine. Write the command. After write the command, delay. Delay. Give the LCD some time to finish its work. Finish its work. Move this another command 0E 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 E displays on cursor blinking call command write delay call command write delay clearing LCD this command the same call command write and delay shift cursor right call write command delay this is cursor at 9.1 position 4 position 4 I call the command and delay all this is write the command to the LED to the LCD to the LCD. Next, after finishing the command writing, we start to send the letter to display. Send the letter to display. So move N this letter move N to A. Move N to A. Date write and delay this is date write we can see the difference between the command write and the date write we can see move the dates to the port 0 is the same RS select for the command is RS to equal to 0. If write the date, RS is equal to 1. Is a difference. For write, RW is equal to 0. This is the same. Is the same. E is equal to 1 for high powers display E is equal is the same so we can see the difference between command write and date write is register signature, register signature. RS is equal to 0 is for command. RS is equal to 1 is equal to 1 for date. For date. Write the date. Write the date. So after the data is right, just wait here. Just wait here. I finish introducing this program. We can see the program again. If we change or add more letter to display, we can just change here. We change here. For example, we give the number 1, 2, 1, 2. So we test this program again. Build. Simulate. You can see N120 120. This is interfacing. This is interfacing for LCD. Interfacing for LCD. This is another example. Another example. Check busy flag before sending data. Sending data. That's the example. We just use the delay. Just use for the delay. Just use the delay. Delay. Because the LCD finish is working. Need some need some time to finish its work. Its work. So we need a delay. We need a delay. But sometimes we don't actually know how long to delay. How long to delay. So we can check the status for the LCD. Check the busy flag before sending data. This is a different. We can see the difference between. No delay, just call command. Call command. No delay. No delay. We can see the difference here. Command call ready. This subroutine. Check the busy flag. Check the busy flag. Here ready. To read the command register, we make RW is equal to 1. RW is equal to 0, which means to write. If we want to know the busy flag, we need to read the register. We need to read the register. RS is equal to 0 and high to no pulse for the E. High to no pulse for the E. We can see the check ready. Set B P 0.7 make P 0.7 input port input port. We need to read the busy flag. So the busy flag is come from the bit 7 bit 7 so we just use the P 0.7 as input port Clearing P02 register select for the access command set B P 0.1 RW is equal to 1 read command allow the register is set register is set read the command and check read blank command and check clearing P.2 clearing P.2 set B P.2 set point for P.2 just for the low to high powers low to high powers wait check the P.7 check 0.7 if P.7 is B is high just return to back or retain if bit 7 is high LCD is busy and no information should be issued to it let's check this program and simulate in Protos just copy the code here Weird. Oh, sorry. I changed the characters to English characters. Now let's simulate this program. Yeah, you can see the results is the same as before. Is the same as before, but we use the different program. We use a different program. The last program we use delay to wait. Use the delay to wait. But this program we check the busy flag. See the busy flag. The difference. We just check the. This is a time sequence for the LCD. For the LCD. This is a LCD date sheet. LCD date sheet. One can put dates at any location in the LCD, and the following shows the address location and how they are accessed. How they are accessed. RS RW and the data bus and the data bus. This data bus, when we write the command, we can use the DB0 to DB6, DB0 to DB6. When the DB0 to DB6 is to this for line 1, for line 1. When the DB0 to DB6 is equal to this for line 2, for line 2, we can see here is different. Here is different. If we send the dates, LCD dates for the DB7 is equal to 1, DB6 is 0 for line 1, DB6 for 1 is for line 2, for line 2. So here is for address from the net is from 0, 0, 0, 0, 0 to 0, 1, 0, 0. This is an example for LCD. LCD. I didn't. I don't want to run this simulation. I give you this example for your assignment. For your assignment. There is something I need to tell you. When you do your assignment, I need you write doc files to introduce your simulate and introducing the meaning of the code. Introducing the meaning of the code. Just like the comment. Just like the comment. At the same time, I need you recording your screen, recording and you record your screen, and send me the video, and maybe you can introduce with your voice when you recording, when you record the screen,
Archie? We were recording while we were simulating it in Proteus. Or you want us to record it while we are writing the doc file?
Sorry, can you speak again?
The previous homework we recorded while we were, as in me, I recorded while I was simulating it in Proteus. But do you want us to record it while we are writing the doc file or while we are simulating the program in Proteus?
When you simulate the program, you can record the screen, your screen. You need the record the screen when you write the doc files. You just record the screen when you use Proteus. When you use Proteus to simulate your program, simulate your program. Okay.
Okay.
You can. Yeah.
I have something to say. Our final exam will be written or assignment?
Your final exam?
Yeah, Laushi.
I know you have final exam, but I can give you more time to finish your assignment. Okay.
Okay, Laushi, it will be better for us if you extend your time for homework. If you give us the deadline next month, then I think it will be better, because with the students doing online classes in outside campus are having a lot of problems, because every subject we need to do online, and we are facing a lot of problems, like to understand the topics. It's very difficult for other subjects. I am not saying about your subject, for other subjects, so we have to spend a lot of time for that. So if you could please extend the time, then it will be better for us. And on the 20th December we have an exam.
I will extend the deadline to end of this end of this month. Okay.
Okay, Laushi.
What is your exam? What day is your examination?
14th January.
For
that is next month, 14th of next month.
Next month.
Yeah, Laushi.
Laushi.
Oh, next month. 14 January.
Yeah, Laushi. 14 January. Yes.
14 January. Okay. Yeah.
Can you go back a little? I have one question, please. Yeah, Laushi. So for instance, if I press the key 6, D2 will become 0, right? Yes.
If no key is pressed, D0 here, D0 to D3 will be 1. Because they connected to VCC. Connected to VCC. If we output 0 from here, 0 from here, and the key 6 is pressed, we can get the 0 from here. Yeah.
Okay.
So we know some key is pressed on this column. On this column.
Okay. Okay.
So if we know some key is pressed on one column, we need to identify which key is pressed. Starting with the top zone, starting with the top zone, the microcontroller grounded by providing a node to zone D0, only D0. Read the column if the data read is all one or ones, no key in that row is activated, and the process is moved to the next row. It grounds the next row, reads the columns, and check for any zero. This process continues until the row is identified. After identification of the row in which the key has been pressed, find out which column the pressed key belongs to. This is an example. Identify the row and the column of the pressed key for each of the following. D3 to D0 110 for 0 for 0, and 100 for the column. We can check the solution. The row belonging to D0 and the column belonging to 3 are 0. So the key number 2 is pressed. Here is 0. Here is 0. So we know here 2 is pressed. 2 is pressed. This D1 is 0. D1 is 0. D3 is 0. D3 is 0. So we know D7 no 7 is pressed. 7 is pressed.
Laoshi,
Yeah.
the 1110 on the row, please, how do you count it?
Please say again.
The 1110 for the row, how do you press it?
Oh, how do you press that?
How do you count it? Sorry, you said I don't understand. D3, yeah, that one. D3 to D0.
This example, I'll give you an example. If we give the output port, this signal, give the output signal from this port. If we get the input from here, port 2 is this signal.
Yeah.
So we can get the result for the number 2. 2. This is just to give you an example how to check which one is pressed. Which one is pressed. For detection and identify of key activation, goes the following steps, following stages. One, make sure that preceding key has been released. Zeros are output to all those. Output to all those. And the columns are read and check repeatedly until all the columns are high. This is step one. When all columns are found to be high, the program waits for a short amount of time before it goes to the next stage of waiting for the key to press. Column output, those are output, zeros output is to all those, and columns to are read for ones, read ones, which means no case is pressed. No case is pressed. So wait until there is a case. There are case is pressed. Keys are pressed. To see if any case is pressed, the columns are scanned over and over in an infinite loop until one of them has an zero on each. Remember that the output ranges are connected to row still have zero initial zero making them grounded. After the key pressed detection, it waits 20 microseconds for the bounce, and then scan the columns again. It ensures that the first key pressed detection was not an erroneous one due spike noise by spike noise. The key pressed if after the 20 microseconds delay the key is still pressed, it go back to the loop to detect a real key pressed. This when we detect one key, some key is pressed, we delay for some times. For delay, for we can illuminate the noise. Illuminate noise. Stage 3. To detect which rows key pressed belongs to all keys down. No, all keys down. Go to here. There is a key is down. Key is down. Wait for a debounce. Wait for debounce. Just give a delay. Just give a delay. Reach all columns. All keys are downs. No downs. Just return to here. Or go to next. Go to the next. Ground next row. Ground next row. This flow chart just give a 0 to a 0. It one zeros one time. One zeros one time. Check all keys ground. If there is a key ground, find which key is pressed. Which key is pressed. Get the scan code from the table and return. We can give the table to the net to the key to the key. So if 1 key is pressed, we can give the natural responding to the key and to show this is a program keyboard program keyboard program. Keyboard subroutine. This program sends the ASCII code for pressed key to P01 P01 P1.0 P1.3 connect to 0 and P2.0 P2.3 connected to column we can analyze this program make P2 an input port give the 111 to the P2 give 111 P2 P2 connected to the column P2 connected to the column, so we can read the result from the P2 so we want to read, we need the P2 uses input port so ground all rows at once all rows P1 connected to zones read the P2 analyze the result and the result if 0 and any result we can get the 0 so we just use the lower 4 bit if someone is 0 we can get the 0 and the results are CJNE compare the result with this result if result is not equal to this result, just jump to here if no case is pressed the port 2 will port 2 0.0 to 0.3 will be 1 so 1 and 1 will be 1 so no case the result is equal to this result if no case is n pressed so loop here if there is a case is pressed just call deny and read again judgment judge this result again if case is pressed jump to here, jump to here, call delay, and read the column, read the column, read the column, and read the press the result and compare to this result, compare to this result. Here, here, give the 0 one those by one those, those by those by those. So we can give the signal to the P0 and read the result, and analyze which one is pressed. If K0 find, go to 0, go to here. This processed those 0 those 0 those 0 is those 0 so next those 2 those 2, next those 3, next those 3 those 3. So if any of this happened, it happened, just jump to for the subroutine for every those subroutine for every those every those. Jump to here, jump to here. After jump to here, SJ jump to find, this find will check the location, check the location for the net, check the location for the net here. This is example. We can simulate with this this diagram. This diagram. We just use.
What is this, Loshi?
Yeah. I give you example how to simulate this program. Okay.
Yes, Loshi.
We just add the keyboard interface to this figure, to this figure. We need button.
Which button?
copy to oh, sorry, I need to change this connection because we use this P2 for the column. We need to change. We change this connection to port 3 port 3. RS to connect to port 3. Be connected to here. I put the program here. Delete. Compiled successful. Simulate. I press here. See? I need to check the program for any error. Any error. Check. We this simulation I have debug it it can work can work. There is something wrong with this resistor. If we use the resistor这个 model type digital we can simulate the successful we can check this program. Build and then simulate. You can see if I use this simulation there's something wrong with this. I guess this resistor we need to change the resistance change the resistance maybe.
What about button, Loshi?
What?
Button. Is this button is same as the before?
Button is the same. Button is the same. Yeah. This simulation, I have debugged it successful. It's successful before our class. When we debug this example, we set this resistor to the model type digital model type digital. So if we don't know how much resistance maybe we change this resistor to resist yeah, this device we change this here we can change this model type to digital. So if we change this model type to digital, we can successful. But if you can try, I give the resistance to 100. And if you want to simulation this example successful, I suggest you change the resistance to digital here. You can try this example. Try this example. Okay.
Digital, Laoshi, digital means, what do you mean by digital?
You can change the
The model type.
model type. Just yeah. Here, you change the resistance to digital type. So if we change it to digital type, we can ignore the influence of the resistance. So the Pro Tools will analyze this figure as a digital signal. So they get no wrong signal for the simulation. So if when you simulate this program, you just need to remember you change the this resistor to the digital type. Okay.
Okay.
You just remember this point. This point.
Laoshi, I have a question, another simulation. Can you go back?
Okay. You see.
I have a question.
Okay. Okay.
Yeah, in the another simulation, that one is not working.
You want to know why this didn't work?
No, just have one question, just a simple one. Laoshi, the resistance one, the VEE, why you connect with a ground and not with a power?
VCC.
No, VEE, another side.
VEE.
Yes, this one, Laoshi. Yes,
Here.
there is a, yes. Why you connected by a ground and not with a power?
This is the VEE control the LCD display. If the power is big, the LCD is lighter.
Okay.
Yeah, this VEE control the contrast of LCD.
And Laoshi, this resistance, we couldn't connect it by power.
Actually, I just simplify this figure. If we can change the resistor, we can change the night of this LCD.
Okay.
Yeah, you can change the resistor. You can change the night of the LCD.
Okay, Laoshi.
Yeah, you can try.
Yeah, I will.
Okay.
Okay, Laoshi.
We have another content for today's class, and if we don't have any questions, we will end this class for today. Okay, let's end this class for today. We will have our class tomorrow.